Hello guys, now let us see about two advanced data structures, Tango tree data structure and unrolled linked list. Let me tell you about Tango tree data structure and its important key features, applications, advantages and disadvantages. Tango tree data structure is an online binary search tree algorithm which uses many subtrees to achieve fast and efficient operations than any other offline tree algorithm. This data structure achieves a competitive ratio of order of log n when compared to offline data structures, which achieves only order of log of n. And it also takes extra memory spaces for efficient operations. Now let us see about the preferred childs and preferred paths and preferred chains. Uh, Preferred child is the any node which is accessed very recently, while preferred chains are the chains of preferred nodes, and the preferred path is the largest preferred chain. Now let us see about the two tree structures in the Tango tree data structure. In Tango tree data structure, mainly there are two types, two different trees. One is reference tree and another one is auxiliary tree. Reference tree will always be in a binary search, perfectly balanced binary search tree, while Tango tree will not maintain a consistent structure and keeps on varying based on the recently accessed elements. Now let me tell about the auxiliary tree a little more. Auxiliary tree is formed using preferred chains, where each preferred chain is converted to an AVL, where each preferred chain is converted to a perfectly balanced tree, and each subtrees are connected with each other such that the in-order traversal of reference tree and auxiliary tree will always remain same. And it is also ensured that the root of the auxiliary tree is in the largest preferred chain or the preferred path. Then whenever non-preferred child is accessed in an auxiliary tree, the whole tree's data structure changes such that the above conditions are met. And similarly, the non-preferred child which is accessed comes to a preferred path. Now let me tell you about its applications. The main two applications are that it is used for very large data sets and used for very large data sets to access the elements very quickly, and it is also used for getting a tendency of persistence in the data structure. And other applications are dynamic sets, file system, caching mechanics, concurrency control, and etc. Now let us see about its main advantages and disadvantages. Advantages are it is efficient, very efficient. It has optimized operations for search and optimized operation for join and split, which are used uh, for changing the tree data structure of the auxiliary tree uh, is implemented in an order of one, and it is also having a tendency of persistency. And its main disadvantages is that it is very complex to implement, and it also has a high consumption of memory. And now my friend will tell about you the unrolled linked list.
So I'll be talking about the unroll linked list, and I will be introducing you to this data structure, and I will also be talking about the advantages of using it over normal arrays, its structure, its application, and the pros. All right, so next slide. Yeah. So normal linked list, in normal linked list, each node accommodates only a single item along with the reference to the subsequent node. But in unrolled linked list, they optimize memory utilization by allowing each node to store, more than one item. Next slide. So why do we need unrolled linked lists over arrays? So there are many reasons. So first of all, unrolled linked list insertions can be done within O of one time complexity, and searching of the elements can be done within O of n. Even in normal linked list, the searching operation can be done within O of n, but in unrolled linked list, they have an edge over normal linked list because of their caching behavior. And there is one small scope of addition in our currently developed code. So then if we introduce a factor called the threshold capacity for each node, all the insertion and deletion operations can be done within O of 1, not just for a few cases, for all cases. And this is a simple block diagram for an unrolled linked list. So now let me describe the structure of the node in an unrolled linked list. All right. So the main part of the unrolled linked list node is data array or chunk. So this part holds multiple elements of or data items within the node. And unlike traditional linked lists where each node can contain only one element, unrolled linked list nodes have several elements. Now, metadata. So along with the data array, there is an additional metadata that helps manage the elements efficiently. So this metadata includes pointers and another variable known as count or size. So pointers link the nodes together, just like your normal linked lists, and count or size. So this is a variable that keeps track of the number of elements currently stored in the node. Slide. So now we'll be looking at some applications of unrolled linked list. So the primary application is database systems. So unrolled linked lists are utilized in database management systems to efficiently manage large data sets, particularly in scenarios involving frequently updated or accessed records. The next major application is file systems. So file systems employ unrolled linked lists for managing file metadata, directory structures, and file allocation tables. And they are also used in caching mechanisms. And there is one more application of unrolled linked list which we have implemented in our project. It's known as sparse matrix. So a sparse matrix is a transformation of a big matrix into a small matrix that will only contain the non-zero elements. Next slide. So advantages of unrolled linked list. So the main advantage is memory efficiency. So a normal linked list can only have one element in a node, but an unrolled linked list can have multiple elements in a node. So obviously they are more efficient in terms of memory. And when it comes to insertion and deletion, unrolled linked list is more efficient since there are more elements that have lesser pointers and reduced memory fragmentation. Memory fragmentation means that when you have free memory spaces, they clump into blocks of memory after memory reallocation and deallocation. And last but not the least, cache performance. So unrolled linked lists can improve cache performance by enhancing spatial locality, reducing pointer overhead, and enabling batch access. And with that, we conclude our presentation. Thank you.